Yes, students, now we will go to the second portion or the second topic on strings only. Now how the same thing here, what they may ask you, that if suppose the charge and the masses of the two balls or particles are same, here only one difference, what they are saying, that you are leaving this one from two certain positions. That means if you leave these two particles or balls from one position, it may happen in two ways. One, as you leave, if the repulsion force is more, that means if the repulsion force is more between them, this will try to repel each other and try to move away from each other. Or if the repulsion force is less, then that means it will try to be nearer to each other. Now how you will find out this one? That means there will be a repulsion force Fe. This Fe is more. If it is more, as you leave this one, it will try to move away apart, and if this Fe is less, it will try to move closer. Now say the distance between them is same. I am keeping the same distance over here, and they have asked you to find out the resultant force, along the string and perpendicular to the string. So you need to understand here, that means along the string and perpendicular, along the string and perpendicular to the string. Along the string, that means this side, and perpendicular to the string means, that means this one. So this is your perpendicular to the string and this is your along the string. Let us also mark the tension over here. This is theta. As we have done for the earlier case also, here also the same thing. One, from M, there is a mass, there is a weight acting, mg, which is acting downwards. Now I am repeating again, they will ask you about the resultant force acting along the string and perpendicular to the string. Now how you will find out this one? Now one simple thing, if you see here force Fe, and then just see these two components. So if I find out these angles, it will be very much clear that which one will take the base component, which one will be taking the vertical component. How we will do that one? Now think this one, if this is theta, then this is also theta. Transversal line between two parallel lines, this and this parallel lines, this is the transversal line. Obviously these two angles will be equal. Now what's the name of the angle? You need to find out. I am not going to tell that one. The class 6 and 7, only class 6 and 7 concept. Why these angles are equal, I am not going to that part now, please. Now if this is theta, then this is also theta. If this is theta, then what will be this angle then? What will be this angle? Now if you see here, this is your 90 degree, then that means this is 90 degree minus theta. Again, if this is 90 degree minus theta, what is this angle? This angle is also 90 degree. This one is 90 degree, clear? And if this is 90 degree, and if I go to find out this angle, then this angle is what? This is 90 degree, out of which 90 degree minus theta goes away. So we will be getting this one 90 degree minus theta. Obviously 90 will cancel out each other, and minus theta minus will go for plus theta. So that means I can easily, now I have told you how you can resolve these angles. So very simple geometry and all. So this part is your theta, clear? Now this is your theta. Then drop a perpendicular from Fe over here. If I drop a perpendicular over Fe over here, then this is one component. This is your perpendicular, this is your angle. Opposite of theta angle is your perpendicular, this is your hypo, then this is your base component. And what we call the base component? Fe cos theta. Now don't ask me why that base is considered as a cos component and why the perpendicular will be considered as sine component. Very basic things from your vectors. Please go through your books, go through some parts of your class 11 vector part. It will be very much easier for you to understand. I cannot explain this one in this class now, clear? Still, if you have any confusion, you let me know. I can have another class on this vectors also. Okay, so Fe cos theta, this part, if this is Fe cos theta, then obviously this is your Fe sin theta. How I can represent? I can represent only if I drop a perpendicular over here, and then this portion will be your, now let me do one thing, let me make this one a continuous line, let this one also be a continuous line. So this part will be your, I'm just rubbing these sections now, otherwise it is looking very clumsy. So this one we can write as Fe sin theta. Clear? So Fe is resolved into Fe cos theta and Fe sin theta. Now if somebody is just raising hand, sir, we have then found out that the component or the resultant force is Fe sin theta along the string, and Fe cos theta is the resultant force perpendicular to the string. Sorry, you are wrong. Why? They have asked you about resultant force. That means obviously you need to understand that there must be more than one force. Clear? So more than one force, that means we have got Fe, we have resolved it in two components. Then what is the other force which will be coming into picture? We have not yet resolved weight. Clear? That's a weight, mg. Now let me resolve now mg also then. This was theta as we have discussed just now. Then if I drop a perpendicular over here, then this one will give you theta, opposite to theta is perpendicular. So this is your base, this will give you base, this will give you mg cos theta. This is your mg cos theta. If this is your mg cos theta which is going along the string, this is your mg sin theta, then how you can make it out? So let me draw a line over here and let me drop, it's not bit straight, let me make it more straight, and then this, if I drop here, then this section I can draw a bit more. So this is your mg, this is your mg sin theta. So this is your mg sin theta. See again, theta, theta, this is your perpendicular. So this is your base. For mg it is mg cos theta, for mg the perpendicular component is mg sin theta. Now you see here, along this point two forces are actually acting perpendicular to the string, and there are actually three forces acting along the string. One tension and two forces, that is Fe sin theta and mg cos theta, away from the direction of the tension. So now resultant force along the string. Resultant force along the string is what then? We have tension which is acting away from the force, so we can write here as T, tension, which is acting this side, and there are two forces acting this side. Now if this case is for equilibrium, it will be asked for your equilibrium case only. As soon as I leave the particles, it will come to an equilibrium position. Clear? For that equilibrium position, this tension T is balanced by summation of these two forces, that is summation of Fe sin theta and mg cos theta. So that's the summation. Now in equilibrium condition you need to understand, then the resultant force I can write in one line, that is T minus Fe sin theta plus mg cos theta equal to 0. So this is your resultant force expression along the string. Now resultant force perpendicular to the string. Now in this case also we have considered equilibrium, that means this one is neither moving up now, neither moving down. So in that case you will have Fe cos theta will be equal to mg sin theta. Clear? You can write in this way also, in resultant Fe cos theta minus mg sin theta will be equal to 0. You can also write it in reverse way also, both are same only. I can take it this side and I can make it 0. Both the conditions are same here in result force perpendicular to the string. So these are the two things which you get when you find out the resultant. So one thing you need to be very clear, when they ask you about resultant, that means there is obviously more than one force. Clear? Now let me ask another question here. We have left those particles or the charged balls, charged particles or charged balls. What they have done, either they have come closer if the resultant force, or if the electrostatic force is less, or if the electrostatic force is more, then what will happen? It will move up. Clear? So if it will move up, or it will move apart, better move apart, or it will move closer to each other. So we don't know that one. So two things may happen. One, if it moves up, that means Fe is more. So if it moves up, that means Fe cos theta, then Fe cos theta will be more than mg sin theta. So in that case, if they ask you about to find out the acceleration of that motion, as soon as the body is left from rest and it starts moving, obviously it will have some acceleration, simple kinematics, nothing else. So what will be doing? So that means Fe cos theta is more, that's the reason it is moving away. Clear? And is moving away against what force? There is also a force over here, you need to understand. Mg sin theta is always acting over there. So that means it is overcoming mg sin theta. Fe cos theta is overcoming mg sin theta, and it is trying to move away. If it is trying to move away, then we can write Fe cos theta minus mg sin theta. This is the resultant force. This resultant force I can write here as mass into acceleration, mass of this charged particle and the acceleration over here. Simple, na? Then A equal to what? We can write Fe cos theta minus mg sin theta by mass. So this is your acceleration over here. Now here what we have found, what we have done, we have thought that this particle is moving away. That means Fe cos theta is more than mg sin theta. I am repeating again, Fe cos theta is overcoming the force of mg sin theta and moving away. So we have taken this one. Think in a different way. If it is just the opposite one, just the reverse one, that mg sin theta is more than Fe cos theta. Simple way, the electrostatic force is less between the charged particles. That means repulsion is less over here. If repulsion is less, obviously this mg sin theta component of mg will be more, and it will overcome Fe cos theta and it will try to move down. What will happen? Simple thing, na? This will be more than this. You will get this answer in negative in that case. If you get this answer in negative, it's simple. That means it's moving down, it's not moving up. Or in other way, you can also think in this way here. We can also write in a different way here. If you want, I am doing it for you. Mg sin theta is more than Fe cos theta. If mg sin theta is more than Fe cos theta, then acceleration is simple, mg sin theta minus Fe cos theta by m. So these are the two functions, one Fe cos theta minus mg sin theta, or this one. Or you can also follow only the single equation only. Here if it comes as negative, it's simple, it is coming down. If it is coming positive, that means it's moving up. Simple case. So I hope you enjoyed this session. This will be very much important for your concepts and all. And let me go to the other one. Here we have discussed on two type of things now on strings. Let me discuss on about a charged particle on an inclined plane, how it can be equilibrium when another charged particle is kept at the foot of the equilibrium. Okay, let's do that one.